Hello, everyone. Today we're going to get to the second unit of Math 8, and we are going to be talking about fractions. And this is also going to be related to BEDMath as well. So let's talk about what a fraction is. So a fraction can be represented as a portion of something. Let's say you have a pizza and you want to split it in half. So if you have one pizza, and you're splitting in two parts, then you can basically say that you're dividing this one by two. Dividing this one by two. And so each one of the respective parts will be half of the pizza, which is equal to 1/2, 1 over 2. Similarly, if you want to visualize it, if we were to split the pizza into four parts, you have one pizza, and if we want to split it into four parts, it'll be 1 over 4. This is what a fraction would look like. Now, we can also do this with multiple pizzas. Let's say we have two pizzas, and we want to split them into three slices. So let's say we split it like this way, and each person can have one of these sections. So then we can split it into three sections, and then each one of these sections here, we can draw like this. Each one of these A, B, and C. Each of them would represent one fraction of the pizza and will represent 2/3 of an entire solid one pizza. Imagine if one of them is a value. So let's talk about adding and subtracting fractions. So first, if you want to add fractions, let's say you want to add up 1 over 2 plus 1 over 4, you can't just add them directly because the denominator, which is a lower number here, this 2 and this 4, they're different with these two numbers. So you have to find a way that can make the denominator the same. So what's one way you can do this? Well, we can see that this denominator, a rule with fractions is we always look at usually the bigger number. So let's say the denominator, the biggest denominator is 4. We can say, okay, so how many times does 2 go into 4? Well, 2 times, because 2 times 2 equals 4. So 1 over 2 will be the same as saying 2 over 4. If this makes sense to you, this will be a lot easier to understand. If it doesn't, we can imagine it this way. If we were to divide 2 on the top by over here by 2, and we can also divide the bottom by 2 here, we would find that 2 divided by 2 is 1, and 4 divided by 2 is 2. So these have 1/2 equals 2 over 4 equals 1/2. You can divide as long as the thing working with fractions is that if you multiply the top and bottom by the same number, or divide the top and bottom by the same number, the fraction doesn't change. So for this problem here, we can solve it as saying, okay, we want the bottom number to be a 2. So we can say that 1 over half is the same as saying 2 over 4 plus 1 over 4 equals 3 over 4. So what does this mean? This means if we have half of a pizza plus a quarter of a pizza, we get 3/4 of a pizza. So what it looks like would be 1/2 and a quarter here. This is what we will have. And this is adding and subtracting would look a bit the same. If we were to have half of a pizza minus a quarter of a pizza, we would have 2 over 4 minus a quarter. And then because the denominators are the same now, we can just straight up just add or subtract the top numbers, which is 1/4. And this would mean that we only have 1/4 of a pizza. Now, this might be a bit tricky if we're dealing with weird numbers. Like let's say we have something like 1 over 27 plus 2 over 9. And we're trying to ask, oh, what happens when you add these two? Well, this is now the moment where you have to kind of understand your times tables, and understand essentially, oh, what multiplied by what or what divided by what makes what. So now we need to know how many times does 9 go into 27? 3 times. This is because 9 times 3 is 27. So this means what we can do is we can write 1 plus 27. And then if we multiply the bottom part by 3, we can also multiply the top part by 3 like this. So what we get is 1 over 27 plus 3 times 2 is 6. 9 times 3 is 27. And then now that we have the denominators being the same, we can say that this equals to 7 over 27. So this is just simple addition and subtraction. The biggest thing you need to note is just practice and knowing how to make the numerators be the same by changing the denominator. Now, another thing that we need to know is essentially just working with mixed fractions, or multiplying fractions. So before we get into that, we can talk about something called the area model. So when you're multiplying fractions, it's actually quite easy. So let's say 2 over 3 multiplied by 1 over 9. When you multiply two fractions, you multiply the top number by the top number and the bottom number by the bottom number. So what you're going to get is equal to 2 times 1 is equal to 2, and 3 times 9 is going to be equal to 27. Now, this is going to be pretty intuitive like this, but there's another thing you can probably think about is if you're ever dealt with a problem dealing with simplifying fractions. So let's say you get 4 over 5 times 1 over 4. What you're going to get is 4 over 20, right? But you can also simplify this further. So how many times does 4 go into 20? Well, I know in my head that 5 times 4 is 20. So this means 4 goes 5 times into 20, meaning you can simplify this as 1 over 5. You can show this by, let's say we divide the top numbers by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Now, this is how you multiply subtractions and you multiply fractions, and generally your teacher would want you to simplify the numbers. You can also divide them. So let's say we have the same problem here, 2 over 3 divided by 1 over 9. So the trick to doing division is that division, you need to know, is the opposite of multiplication. So saying 2 over 3 divided by 1 over 9 is the same as saying 2 over 3 multiplied by 9 over 1. And what you can do here is now write 18 over 3, and that's going to be equal to 6, if this makes sense too. One way we can express these is using something called the area model. So let's say we're doing 1 over 2 times 1 over 3. If they want you to visualize it, you can say, okay, we can visualize this as a 2 times 3, take the denominators only, and visualize it as a rectangle like this. So let's say it's a 2 by 3 angle here. So let's say 1 over 2 would mean we can cross out 1 over 2 here, 1 over 2, and then we have 1, 2, 3. And then since we don't have 1 over 3, we can only cross out one of them here. So what we get is we're going to have only one of these squares filled out of the 6 remaining. So this is going to be equal to 1 over 6. This is another way to solve these sort of problems. We can repeat it again with 2 over 3 times 1 over 9, although this one's going to take quite a bit of a long time. But how we can express this is, let's say we have a grid of 3 here, 3, and then 9. This is not a good drawing, but you can understand. So 1 out of the 9th would be equal to just this bar here. And then 2 over the 3rd would be equal to, let's say, just crossing here. So as you can see, we only filled out two boxes, and then now we can understand how many boxes there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 27 boxes in total. So this is another way of solving it, where you can visualize it this way. Now, another thing we can understand is we can divide and fractions and involve them with integer numbers. So this is first thing is we can express our fractions as a whole number as well. So let's say we have 5 over 3. We can say, okay, how many times does 5 go into 5? 3. This is what's asking, right? So we know that 5 over 3, we can simplify it as 1, 2 over 3. 1 and 2 over 3. Why is this? Well, it's because 5 over 3 can be imagined as 5 plus well, sorry, 3 plus 2 over 3. And then you can simplify it as saying, okay, 3 over 3 plus 2 over 3. And then 3 over 3 is going to be 1, so it's 1 plus 2 over 3 is equal to 5 over 3, like so. This only happens if the numerator, the top number, is greater than the denominator. By simplifying it this way, you write it as 1, 2 over 3 like this, instead of saying 1 plus 2 over 3. And there's going to be some problems where, let's say you're given 5 over 3 multiplied by 9 over 8. How are we going to do this? Well, if it's multiplication, you just multiply the top number by the top. So 5 times 9 is 45, and then 8 times 3 is 24, like this. But there's also problems where, let's say, you're going to add them together, like 5 over 3 plus 9 over 8. And this is going to be a bit tricky, but how you can do this is you can multiply 3 by 8 over here, and 8 by 3, this part by 3. This is the same because you're multiplying the top and bottom by the same number. So what you're going to get is 40 over 24 plus 27 over 24. The answer is going to be 67 over 24. And the tricky part here is we're going to think, okay, how many times does 67 go into 24? It's going to go at least 2 times, because 2 times 24 is 48, and 67 minus 48 is equal to 19. So it's going to go into 2 times, and then 19 over 24, because that's the remainder. That's the remaining fraction that's not in there. So now that we understand all these about fractions, this entire unit is going to be focused on just practice questions based off of what we learned, as we said. You should generally express answers as a whole number, like 5 and 1/2, whole number with all the fraction remaining and whatnot. And another problem you can do is 27 over 19 plus 85 over 13. This is going to be very hard because you have very difficult numbers to deal with. So what you do here is 27, you can still do the same logic. 19 times 85 plus 13 times 19 divided by 85 multiplied by 19. This one you might use your calculator a bit, but I'll just leave this one for you guys to solve. Using the same problem, you can probably just practice your math skills and then simplify it to a mixed number like this. Anyway, that's it for today. Thank you so much for listening.